Okay, next one for rational inequality. So we have 5 steps in solving rational inequality. So number one, write the inequality in standard form. Number two, find the critical value by finding zeros of the inequality. Number three, construct a sign table. Number four, use the table to determine which intervals satisfy the inequality. Then, highlight the intervals in the number line. The number 5, write your answer in set and interval notation. So here we have an example. X minus 7 over x minus 1 is less than 0. So first, we write it in standard form. Since this is in standard form already, let's proceed to step 2 wherein we find the critical values. So let's solve for the values of x in the numerator and denominator. So in this case, we'll obtain x is equal to 7 and x is equal to 1. Okay, so in constructing the sign table, of course, we'll have here 3 intervals. Since we have 2 critical values here, which are 1 and 7, we'll have here x is less than 1, and then x is between 1 and 7, and x is greater than 7. Okay, so we can use test points for each inequality here. So the factors here that we will test is x minus 7 and x minus 1. And of course, the whole expression on the left-hand side. So again, we can use test points here. For each inequality, for x is less than 1, we can have -1. And then for between 1 and 7, that's 2. And then x is greater than 7 is 8. It depends on you. Okay, so of what value will you substitute? Okay, here. So for instance, x minus 7. So if we substitute -1 there, -1 minus 7, that's -8. So we'll get the sign, which is negative. And then for x is equal to 2, so 2 minus 7, that's -5, also negative. And then 8 minus 7, that's 1, which is positive. And then for x minus 1, -1 minus 1, that's -2, so the sign is negative. Then x is equal to 2, that's 2 minus 1, so that's 1, that's positive. And then 8 minus 1, obviously it's 7 positive. And then all we need to do is to multiply, okay, the signs on each column here. So negative times negative, that's positive. Negative times positive, that's negative. And then positive times positive, of course, it's positive. Okay, so aside from this, we can have the technique of putting zeros on our critical values. So for instance, for 7, okay, so of course, x minus 7 will be 0 if x is equal to 7. Okay, so as you can see here, if we have this form, the x is positive, all of the signs in the left here is negative, and then in the right is positive. Okay, for x minus 1 naman here, we have 1, of course. So again, in the left, that's negative, and then in the right, that's positive. Now, let's interpret this. So since we are looking for less than 0, obviously there will be no included value for the critical values here. So since it's less than 0, the sign here should be negative. Okay, so let's get the inequality x is between 1 and 7. So if we have the number line here, let's illustrate, let's graph. So 1 and 7 is not included, of course. So that's a whole. And then x is between 1 and 7. So we'll highlight here in the middle. So therefore, our solution set for this inequality is 1 and to 7 exclusive. Okay? 1 and 7 is not included. Another example, x plus 2 over x greater than 4. So as you can see here, it's not in the standard form, uh, we need to have 0 on the right hand side. Okay, so let's solve this. Let's add negative 4 both sides. So that's x plus 2 over x minus 4 greater than 0. And then finding the LCD, that's x. So simplifying that, that's x plus 2 minus 4x over x greater than 0. Okay, so x minus 4x, that's negative 3x plus 2 over x greater than 0. Now, let's find the critical values here. So for the numerator, that's x equals 2/3, and then for the denominator, that's x equals 0. Another strategy when it comes to the sign table is we put our critical values, okay, in the lines here on our second and third column. So again, since we have two critical values here, we have three inequalities, which are x is less than 0, and x is between 0 and 2/3, and x is greater than 2/3. Okay, as we all know, x will be 0 if x is equal to 0. And then negative 3x plus 2 will be 0 if negative 3x plus 2 is equal to 0, and that is 2/3. Okay, so let's use again the strategy. Since x is positive here, we have positive sign. The left of 0 is negative, and then the right will be all positive. Okay. Then next one, if we have here negative 3x, we'll reverse it. Okay. On the left of 0, that's both negative, positive rather. Sorry. And then for the right hand side, that's negative. Okay. So we reverse the signs. Okay, so if x is positive, the sign is positive, the left hand side of 0, the left hand of 0 is negative, and then for the right is positive. Well, if x is negative, the left is positive, and then the right is negative. Okay, now let's try to multiply the signs on each column. So that's negative, positive, and negative. So in this case, we are after with greater than 4. Okay, greater than 0. Correction. So greater than 0 here. Okay, in this case, we are after with the positive. Okay, we are after with the positive. So we have 0 and 2/3. They are excluded again because we don't have an equal sign here. So in this case, we'll highlight the inequality x is between 0 and 2/3. So we have here our solution set as 0, 2/3, exclusive, of course, 0 and 2/3. Next example, x plus 6 all over x squared plus 6x plus 8 is greater than or equal to 0. So in this case, we have here three critical values. Okay, so for the numerator, that's x is equal to negative 6. And then for the denominator, we have negative 4 and negative 2. Okay, so again, we use the strategy that we put all our critical values here. Negative 6, negative 4, and negative 2. So always remember, it's always increasing. Okay, so just imagine that this is number line. Okay, this is number line. So the values here should be increasing. So negative 6, negative 4, and negative 2. Then we have your different factors, x plus 6, x plus 4, and x plus 2. And then our rational expression on the left-hand side. And then, since we have three critical values here, we have now four inequalities. So what are those? So let's just put first the zeros here. So x plus 6 is negative 6, x plus 4 negative 4, and then x plus 2 negative 2. And so first inequality, x is less than negative 6. The next one, x is between negative 6 and negative 4. X is between negative 4 and negative 2. Then last one, x is greater than negative 2. Okay, now, as you observe, all the signs of x here are positive, right? So in this case, all the left side of 0 is negative, and then all the right side of 0 is positive. Okay, so that's a great strategy for us to have our signs here. So as you can see here, in x plus 6, we have negative on the left of 0, then the rest is positive. And then x plus 4, again negative on the left, and then the rest is positive on the right. And then x plus 2, negative on the left of 0, and then for the right, we have here a positive sign. Then again, all we need to do is to multiply. Okay, multiply the signs here. So negative times negative times negative, so that's negative. Okay, or you can apply, of course, here if you substitute the sign. So negative over negative times negative, that's still negative. And then we have positive over negative times negative, that's positive. So positive over positive is positive. And then we have here positive over positive times negative, so which is negative. So that's negative. And then we have here all positive, so that's positive. Now, since we are after with greater than or equal to 0, so look at the two inequalities here, wherein we have x is between negative 6 and negative 4, and x is greater than negative 2. Now, as you can see here, we have an equal sign. Okay, so if that's the case, we need to include the values of x in the denominator. Okay, in this case, we have x plus 6, which is negative 6. So negative 6 is included. Okay, so always remember, look at the numerator if there is an equal sign here. Okay, so now let's draw a number line. Let's graph that. So we have here 3 critical values. And then in this case, as you remember, negative 6 is included. And then the inequalities that are included here is from negative 6 to negative 4 and negative 2 and so on. So we have here our solution set. Negative 6 included, comma negative 4 not included, union negative 2, comma positive infinity. Last one. So here, in this case, you should be familiar when it comes to the exponent, okay, of the given here. Okay, so if it is even, obviously, all the signs here is positive. Okay, for x plus 3, all the signs are positive. While here, 1 minus x and 5 minus x, we use the case. Okay, since it's odd, 15 and 11, as their exponent, we still use the case or the strategy that we have done earlier. Okay, so in this case, we have 3 critical values again, negative 3, 1, and 5. So let's put that. And then we have here the factors and the inequalities. Okay, and let's put the zeros here. So remember again, if it is even, all the signs are positive. Okay? Regardless of where 0 is located, all is positive. Okay, well here, we will use our strategy earlier. So in this case, the sign of x here is negative. So on the left of 0, that's positive, and right, that's negative. And same with 5 minus x, positive, 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 and then negative. Okay, so now we have here 1 minus x raised to 15, that's our numerator. And then for our denominator, x plus 3 raised to 20, and 5 minus x raised to 11. Okay, so in this case, for the column of x is less than negative 3, they are all positive, so that's positive. Also with this column of negative 3 to 1, that's positive. And then we have here negative for the numerator, divide it by both positive times positive, which is negative. Okay, and then for the last column, we have here negative over positive times negative. So that's negative, and negative over negative is positive. Okay, so again, let's look at this equal sign. Okay, so there's an equal sign here. So we have the critical value for the numerator as 1. So therefore 1 is included. Okay, and also since this is less than, we are after with the sign minus. So we only have one solution set here. Okay, so we have the inequality between 1 and 5. Okay, so let's present here. And remember again, 1 is included. And our solution here is between 1 and 5. Okay, where 1 is included. Okay, 1 is included.